Hello, everybody. This is Miss Jungle, Maddie Jungle, AP Calculus teacher over at Abraham Lincoln High School. I'm going to go ahead and start some of this through the Google Hangout. I know there's nobody watching right now. I'm trying to email one of my students so we can get him at least to participate. So what I'm going to do is I'm going to do this all through a Google Hangout. And so that all the video is going to be seen in this screen right here, but I'm also going to do a back channel, and that's going to be through today's meet. So let's say that you're watching this at some other time and you want to comment or something like that. You can go ahead and go to todaysmeet.com/APCalculusAB. 4 and hopefully I'll be able to edit this video later and insert that link there, so you can go ahead and see some of the dialogue and conversations that we're going to be working with as we go through these different topics. So I'm going to go ahead and start by introducing some of the stuff for the webinar. So hopefully one of my students is able to watch so we can at least have some interaction here. But while you are in the webinar, you can raise your hand by basically typing into the box. So if you're going to watch the feed with us, that'll be what it looks like. I'm going to go ahead and email a link really quick. We will have discussions at today's meet.com/APCalculus webinar 4. Make sure that that's hyperlinked. All right, so I've sent out a message, so hopefully we'll have some other people join us, but we can still kind of talk through some of these topics. What we're going to talk about today is going to be the fundamental theorem of calculus, so a really big one when it comes to that AP test. So I'm going to go ahead and do some screen sharing with you so you can kind of follow along with me as we go. So again, hopefully your packet for you so you can follow along with all of the examples, but we will be starting with the fundamental theorem of calculus. So those of you who are not familiar with the fundamental theorem of calculus, it does come in 2 parts. And one of the things that I would like to note is that students get confused and think that both parts apply at the same time. So we actually use each fundamental theorem of calculus for different purposes. Okay, so there's a part 1 and a part 2, but each part actually does something different. So we're going to use them in different ways. So I'm going to go ahead and switch over, and hopefully you can see this fundamental theorem of calculus. Oh, I just caused all sorts of trouble. There we go. All right, so here is our handout, and you can see that we've got different things that students should be able to do. So you should be able to use it to evaluate definite integrals. So this is that basic piece that your teacher might have even started with, right? I take the antiderivative and then I plug in the endpoints to find the value. You can also use it with different applications. So you know, it looks if I take the antiderivative of the derivative, it's the original function f of b minus f of a, and you've also got that whole idea with the initial condition. Value at b is equal to the value at a plus the integral from a to b. And that we'll see that better in a different context. You can also calculate the average value, okay? And we're going to point this out several times, but the average value piece is very, very important because they're going to be very specific about what's the average amount, what's the average value, and you're using this idea right here. You're taking the integral and dividing it by the width from the lower limit to the upper limit. And then, of course, the favorite is the other fundamental theorem. They love referring to this over and over and over and over again. So make sure you keep an eye out for when they're going to apply. So let's go ahead and get started on some problems. So if I take a look at the multiple choice that we have here, calculator not permitted here. So you might look at this initially and think you've got something with an x squared and an x. So maybe I'm going to do some u substitution. Actually, think about some algebraic manipulation first. So when I'm taking a look at this problem, at first when I took a look at it, I did think u substitution, and then I also was a little bothered by this x plus 1 in the denominator because I was worried that I was going to have something that was undefined. But it's okay because that's only undefined when x is equal to -1, and my integral's from 1 to 2, so we actually don't have any issues. Now the trick with this is I'm going to do some algebraic manipulation. So I'm going to actually factor out the numerator. You see a rational function. This is especially true with limits, but also true in this case. When you see a rational function, you should totally factor it out. Okay, so now if we look at this here, I've got my factors. I'm going to go ahead and cancel out that x plus 1, and I can totally do that because my integral -1 where I would have that trouble spot. So I'm basically left with the integral of x minus 1 from 1 to 2 dx. Well, this is x squared over 2 minus x from 1 to 2. And yes, AP is going to expect you to do some of these calculations in your head. It doesn't have to be super pretty. You just have to be able to figure out which value it is. So I've got 2 squared over 2 minus 2 minus the quantity 1 squared over 2 minus 1. Make sure you're careful with your parentheses. If I don't remember the parentheses for the second half, I'm going to have a big error. So make sure you're very careful about that. So that's going to be, this is actually 4 squared, or 4 over 2 is 2 minus 2. So this cancels. What a lot of students will mess up is they'll forget that you still have that minus sign there. So I have a -1/2 minus 1, which is -1/2, which turns into 1/2. So my answer is going to be A for this problem. So again, it looks really scary. Make sure you keep in mind when you have a rational function, they really like it if you factor. All right, taking a look at this one, I have the integral from 0 to k of 2kx minus x squared dx is equal to 18. Then k is going to equal what? So the reason why I think this is so clever is because it looks really complicated by introducing this idea of the k. It's really not that. So one of the things that I would love for you to try when you're doing these problems on the AP test is even if you're not sure what to do, try something out anyway. So maybe I'm thinking to myself, okay, like I could take an antiderivative, so maybe I'll just try it. Remember that k is a number. So when I'm taking the antiderivative here, I know that I am going to have it be 2k squared over 2. So notice I didn't take any special antiderivative with the k. I just kind of treated it like one of the numbers. So that's minus x cubed over 3, and then I have my limits of integration from 0 to k. And you're like, that's great, Ms. Jungle, but I mean, how would I even do after this if I didn't even come up with this plan to begin with? That's okay, just try stuff and things should pop out at you. So I'm like, okay, I have an antiderivative. Maybe if I plug the endpoints in, that'll do something for me. I don't know. So I'm going to try it out. I have, I'm going to actually simplify. The 2 over 2 just cancels. So I have k times k squared minus k cubed over 3. And that's plugging in k. Minus, and then when I plug in 0, I'm just going to get a big old 0, right? Anytime I have a polynomial antiderivative and I plug in zeros, I do get zeros. Now make sure you're careful and you don't do that and assume that it'll be 0 when you have different kinds of functions, especially trig functions. Typically, they'll throw in a cosine, so they're checking to make sure that you're actually plugging in that 0. So be aware of that. So now I'm like, okay, simplify this. I've got k cubed minus k cubed over 3. That's equal to 2k cubed over 3. Great. Like, I got that, but what do I do with it? I'm going to go back and reread the problem again. If I take a look at it, okay, I know that this integral, I'm reading it, if the integral is equal to 18, then, oh, the integral is equal to 18. So I know that 2k cubed over 3 is equal to 18. I'm going to multiply by 3 halves, which gives me that k cubed is 27. As a hint, even if you're not sure, like let's say you're really bad at fractions and you couldn't figure out that 3 halves times 18 was 27, the hint that I'll give you is they typically don't pick stuff that's not a perfect cubed if you need to take a cube root. So even if I wasn't sure, I know perfect cubes are 8, 27, you've got 64. I'm looking for one of those numbers to pop up. 8 would be too small, 64 would be too big, so it's probably 27. So even if that fraction math's not good for you, remember AP is planning for you to be able to do this in your head. All right, so if I take the cube root of both sides, I get that k is equal to 3. So that gets me letter C. All right, so remember, for a problem like this, just because you theory, just try something and reread the problem each time you think you get a little bit further. You'll be surprised by how much each step will help you out along the way. Right, on to number 3. So what is the average value for the part of the curve? Y equals 3x minus x squared, which is in the first quadrant. So the first thing that actually pops out to me is that they use that magical phrase that we talked about at the beginning. They use this phrase, average value. Okay, so I'm going to be able to kind of draw this curve. I know it's 3x minus x squared, so I'm that it intersects at 0 and at 3. Oops. Okay, and I know because it's a negative in front of the x squared, I do have a downward facing parabola. So don't forget those graphs. Always draw them out. I always draw them. I can't remember them. And they want to know the area, average value, sorry, for the part in the curve that's in the first quadrant. So this right here is my first quadrant, this right here. They want to know the average value, which in my head I think, okay, anytime they're talking about an average value, they're probably asking this integral right here. Okay, 9 times out of 10, I can't remember any where the average value was not using this integral, but I don't want to like have you find that one time and say, oh my gosh, Ms. Jungle, you were wrong. Like most of the time, every time I've seen it, at least, it's been using this integral. So I know it's in the first quadrant. So that's intersecting from 0 to 3. So I have the integral from 0 to 3 of f of x dx, right? And then it's 1 over 3. Well, the function is 3x minus x squared dx. And then when I go ahead and take the antiderivative, I'm going to give you a little bit to work it out for yourself while I make sure some of the tech stuff is going on okay. But really, I want you to try to work this out, the antiderivative for you. And if you need some tips and tricks for simplifying, I'll go over that in a couple of minutes. All right. So I'm going to go back to sharing my screen. Excuse me for the mirror for a sec. All right. So when we're taking a look at this, we know that we have 3x squared minus x cubed over 3. Ooh, I forgot the over 2. And then I've got the 1/3 in front. And this is from 0 to 3. Now, remember what I said before. If I have a polynomial antiderivative, when I plug in 0, I can take advantage of the fact that it is going to give me 0. But keep in mind, you do get individual points for each little piece, right? So each piece that you get a point. So you're not necessarily aiming for all 9. You're trying to make sure you get about 4 or 5. If you're shooting for something a little higher, that's great, but about 4 or 5 per problem. Okay, and then they say how many cubic feet of snow are on the driveway at 9 a.m. So remember, we have 2 forces, and when I simplify that out, I know the amount that is accumulated is that integral from 0 of 9 f of t dt. That didn't show up as pretty as I wanted, so f of t dt, and then I subtract the amount that I removed at 9 hours. Well, the good news is that I can find that amount by just plugging in 9 to my piecewise function that I just had up here. 3 times 3 squared. Oh, I think that I have this right. I have 108 times 9 minus 631. And so that is going to be equal to, hopefully I'm using my calculator, you don't want to hurt yourself. 13.5 minus 9 over 3 is going to simplify to that 3/2. Okay, so 13.5 minus 9 is 4.5 divided by 3, so 9/2 times 1/3. It's going to give you that 3/2. So try to break it down as many ways as possible. It doesn't matter if you're perfect or you've got work everywhere. What matters is that you can get it down to which one of the multiple choice it is. So make sure you're getting it as close as possible. All right, number 4, if the rate at which people enter an auditorium for a rock concert is modeled by the function r, given there, and again, there's a calculator allowed, so I don't necessarily care exactly what that function is, because I know I can always trying to trick you or anything. Make sure they're just testing that you know the theorem. 10 people per hour. No one is in the auditorium at time t equals 0, so that's tough. It's the line shown. If f of 0 is 5, then f of 1 is equal to. So here's one of the relationships that I do like to talk about. Whenever I know something to do with the graph or the y values or like that, I like to draw myself the relationship. So I know that I have f prime of x given. I do have the y values, and I'm trying to go to f. So I know I'm going to have to go backwards, which means I'm going to have to take the antiderivative. The big thing that students forget with this, though, is they do have to use that initial condition. So make sure you're careful. All right, so I'm going to take the, because there's always that arbitrary constant. So for how much jungle, I don't have an equation. Panic. You can write an equation from a line, right? All you need is 2 points. So if I take a look at my graph, I have 606 plus your initial amount, which is 0. I made sure I took a look at that. So then I went down 6 over 1, so a slope of -6. Okay, because I'm going to use my calculator. Anytime it's a calculator, okay, question for f prime of x. You doing anything differently? All right. Taking a look at letter C. Total wait time for all the people in the auditorium is found by adding that each time the person waits, starting at the time the person enters and ending with when the concert begins. The function models the total wait time for all people who enter the auditorium before time t. The derivative of w is given by w prime of t is equal to 2 minus t times r of t. So they want you to find w of 2 minus w of 1, the those who enter the auditorium after time t equals 1. So I actually had to wrap my brain around this one for a little bit. It's going to be that +5 at the end. And now maybe I forgot what I was doing. Oh my gosh. And now I'm going to freak out and not answer the problem, no, I'm going to reread it again. The graph is the f prime, the derivative of f, is the line shown in the figure above, an amount, because they're asking me for the total wait time, okay? And that's after time t equals 1. So I'm going to be taking a look at taking an antiderivative, right? I'm going from a rate to an amount. So I'm going to take the antiderivative from 1 to 2 of 2 minus t times r of t dt. Okay, so that's where I'm going to start. And guess what? I can use a calculator. There is no reason not to just use my calculator. I get 387.5. Okay. All right, letter D. On average, how long does a person wait in the auditorium for the concert to begin? Okay, so I'm going to just point out right here, they're using this word average. So in my head, I'm thinking a constant to a variable. It's very long. Well, that's not a rate. That's like an amount of time. So in my head, I'm thinking, so if I have the derivative of an integral from a constant to a variable, I know by the fundamental theorem of calculus part 1, that's just going to be that same function, but with, and use the model for the total wait time from part C. Okay. If there is a derivative to that upper limit. So sometimes the upper limits of that I have the antiderivative that I used from above, right? Because this represents the wait time. So it's going to be 2x. So I'm going to look through and see which one of these matches. It's letter E. Ooh, 7 looks super fun. It looks really scary. Some students are like, oh my gosh, what if I go past 3 decimal places? The AP graders only know with or familiar with. So let's say that I have this function from, and I look that it's from -2 to x squared minus 3x of e to the t squared dt, and they're asking me at what value of x is f of x a minimum, okay? So I'm thinking to myself, okay, I've got maximums and minimums. Let's pretend that I don't have that really scary integral right there. If I was just being asked to find a maximum or minimum, what would I consider? Well, I'd probably consider where the derivative. Take a look at this. You're thinking to yourself, oh my gosh, they didn't give me a do this. One of the things I always look for on these AP questions is, do they ever separate terms by a plus or minus in an integral? So f prime of x is equal to e to the x squared minus 3x squared power, but don't forget to chain, times 2x minus 3. All right, so that looks like a really scary, this first antiderivative here, no problem. Okay, they love to make you use the fact that e to any power cannot be 0. If you think about an exponential function, it has that horizontal asymptote f of x. All right, and maybe I'm still lost, right? So I'm gonna kind of take a look like, okay, I've taken an antiderivative. Do I know anything about f of x? Oh, wait, they gave me this table up here. So let's see what happens. So I've got 3 times 13 minus 3 times 2 minus the quantity, don't forget to put this in parentheses, 5 times f of 13 minus 5 times f of 2. Do I have f of 13 and f of 2? F of 13 is 6, f of 2 is 1. So I've got 5 times 6, which is 30, positive. If I plug in 0, I'm going to get, okay. And I know that I have a minimum at, and you do get a value of 8. Okay. So one of the things that is this several times, they really like to use the fact that e to some power can never equal 0. So even though it looks scary, if you can stay calm and realize that that doesn't have to be scary because it can never equal 0, so you don't have to worry about solving. So make sure you're watching out for that, but take a deep breath and just do what you think you would do, and odds are you're going to turn out with something that looks right. All right, oh, this is a classic one. I love this one. So if I take a look at this, I have the graph of g prime. So I'm going to make sure I make a note of that. The function g is defined and differentiable on this closed intervals and satisfied g of 0 equals 5. I know I'm going to need that for sure. The graph of y equals g prime. The derivative of g consists of a semi. I would like to take a look at number 11 and 12 real quick before we move on to the multiple choice, because I think these are really good. So suppose that I have g prime is less than 0, so I know that my derivative is negative for all the x's that are bigger than or equal to 0. And then they give me that f of x is equal to this fun integral. We love that. Which of the following statements is false? Okay, so does f take on negative values? That's what I'm going to ask myself. If I take a look, x is greater than or equal to 0 for everything. So I know that, say that I have all this area, the derivative is negative, so the function's always decreasing, but that doesn't necessarily here plus this right here. Okay. I do know that f is continuous, so I know that that can't be false. This piece right here is going to actually come from one of your fundamental theorems. But one thing that I do know for sure, so if I want to know if f is an increasing function, f prime of x is going to be equal to x times g prime of x. I know that g prime of x is always negative. And then I have plus 5. Okay, now guess what is so great about the AP test? That's it for G of 3. That's it. You don't need any more. Don't simplify it. Don't do that. This is good because it is completely numbers. So this is your G of 3. If I take a look at G of negative 2, I'm going to need to take a look at this area right here, x cubed squared. I'm plugging it in for t. And then I do need to make sure that I chain by multiplying by 3x squared. So I am going to get answer of letter E. So let's take a sneak peek over here at some of the free response questions. So taking a look at number 1. This is actually a pretty standard related. It's kind of like related rates, but you're dealing with a lot of the relationships between a function and its derivative and its antiderivative. So there is no snow on Janet's driveway when snow begins to fall at midnight. So what I'm thinking right now is I'm making a note to myself, the amount of snow, let's see if I have the amount of snow at time t equals 0 is 0. So that's kind of the note that I'm making to myself in my head before I even continue. All right, from midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by this function right here. Now my calculator is allowed, so I'm not really paying that much attention to the function itself because I know I can always use a calculator. So I have this f of t, cubic feet per hour, where t is measured in hours since midnight. Removing snow at 6 a.m., so that's when t is equal to 6. It's really nice that they gave that to us. The rate g of t in cubic hour at which Janet removes snow from the driveway at time t hours after midnight is modeled by this beautiful piecewise function here. And I say it's beautiful because it is nothing but constants. You could not ask for a better gift. Okay, so the first question they ask is how many cubic feet of snow have accumulated on the driveway by 6 a.m.? All right, so they give me a rate that snow falls. So I kind of think of this relationship, and I just came up with this with my students. I think it might have been, it was yesterday. There's this fundamental calculus relationship that we've been studying where you've got your area, sine of x. And I don't need to simplify it. I don't need to make it pretty. I just need to make sure I put all my pieces together. Okay. So that is how I'm going to take the derivative. Now notice this looks really intimidating right here. Okay, this f prime piece probably known as the derivative. And then the next level is like this. AP is not going to give you anything. The big idea of calculus that the AP test tries to work, trying to give you like hard math, like algebra stuff. They're just trying to give you things that are going to make you think. Okay, so when I looked at this, I just started with like, okay, pretend I don't know anything else. I'm just going to take the derivative using the rules that I know. And then the other piece, so I do know this rate. So I'm starting off with a rate, and I'm thinking to myself, okay, they're asking me to get to an amount. So what process am I going to have to use? Well, that means if I'm going left on my chart, I'm going to have to take an antiderivative. Okay, so that means I'm going to take the integral on the interval from 0 to pi and to justify your answer. Okay, so if I have some values, that means I'm probably looking at critical points. And so I'm going to be taking a look at when g prime of x is equal to 0. And oftentimes in the AP rubric, I'm sure your teachers will let you know this too, you get points for just like acknowledging that you need to consider that g prime of x is equal to 42.274 cubic feet. Now keep in mind, remember with AP, they do need the first 3 decimals to be accurate. So you can either cut it off or you can round it off, but to 3 decimals, it has to be accurate. So make sure you're very careful about that. All right, moving on to letter C. Let H of T represent the total amount of snow in cubic feet that Janet has removed from the driveway at time T hours after midnight. Your square roots and squares and stuff, right? Underneath here, you can't get something 0. So what it sounds like they're asking you to do is make this new function H of T. Now this represents Janet's removal rate. What they're asking me for is how much Janet removes. So they're asking me again to go from a rate to an amount. So I know I'm going to have to take sort of antiderivative. Remember, moving to the left on this diagram is harder than moving to the right because you're always going to have to deal with an arbitrary constant. So just keep that in mind anytime you're using these relationships. All right, so I know that I'm going to take the antiderivative of each piece, but I also have to use my initial conditions in order to solve. So the antiderivative of 0, fortunately, is just 0. And look, there's that initial amount. So since I started with 0 snow, and this is 0, the C value here is just 0. And that's going to get, I have f of sine of pi over 6. Okay. So this is what I have so far for her removal rate at this time. Now, after 6 hours, since she still hasn't started shoveling, so using the integral that I had up here, that's going to be the integral from 0 to 3 of the square root of 4 plus t squared dt. I know for certain that this will be positive. Okay. I also know that I consider this is equal to 6. Janet's, which is equal to f of 0, and guess what? I started shoveling yet. So that's why I know I have this point 6, 0. So when I plug in 6, so I have 125 times 6 plus c. I am going to get, hey, I took a look at the critical points. I took a look at the endpoints. So in this one, it's going to be my maximum. And that's using EVT. And any time I see the word maximum, that's what I'm thinking. So that was a 5t minus 700. And one more bonus one for this recording. Take a look at 27. So they give me a piecewise linear function, and notice everything is defined in pi, so they like to be super tricky with this one, right? So they want you to find the integral from negative 2 pi to 4 pi of f of x dx and show the computations that lead to your answer. So keep in mind that they have things defined differently depending upon what's going on. So f of x removes some snow since this time. So hours, I know that at t equals 7, h of t is about equal to 125 times 7. So I'm using this second piece right here to solve for the amount at 7. And I get a value of 125. Okay, so I know when I have 7, then I can, I know that at time t equals 7, I have 125 cubic feet of snow taken away. So when I take a look at this, I have 108t plus c, so 108 times 7 plus c has to equal, so 4 pi times 2 pi over 2. Overall, I'm going to get, go ahead and put that one in my calculator in case you can use substitution on this, use whatever method you like, but it is going to come out times 7. For the purposes of our webinar, I am going to stop this topic right here. Okay, so I know that I have 108t out of this. I got some of the bugs worked out at the beginning, so thank you so much for being patient. 7 and 9. Okay, so that's a lot of work done for just something that looks really, really, really simple. And I think where a lot of students would get tripped up. So if you are watching, if you could just let me know by going to todaysmeet.com/AP Calculus AB Webinar 4. So I'll write that down. So I'm actually not going to switch rooms because I know we have some people out there watching. So that's an A. Okay, so todaysmeet.com/AP Calculus Webinar 4. I'm going to leave that up. If you're watching, please send me a message on there just so I can know how everything's going, if you can see everything, and I can just kind of monitor what's going on. I subtract the amount that I removed at 9 hours. To my piecewise function that I just had up here. So I know that I have this right. I have 108 times 9 minus 631. And so that is going to be equal to, hopefully I'm using my calculator, you don't want to hurt yourself, 20 posts on there if you're the other person out there watching. I just want to make sure everything's okay. So again, you're looking for about 4 Calculus Webinar 4. If you're watching this recording at a later date, I'm going to leave that chat room and check it periodically. So if some questions come up for you, make sure you leave me a message and an email address to contact you at, and I'll go ahead and answer your questions based upon what you've seen in the webinar. Okay? All right. So the next topic that we had scheduled for tonight is area and volume. All right. So this is a pretty heavy. A lot of students really struggle with it, but the nice thing is that especially on the FRQ problems, it's very predictable the way that they grade them. So area between two curves, this one's pretty straightforward, right? You just sketch a region and determine the points of intersection, draw a small strip either as dx or dy is slicing, so you're gonna have to be conscious about what variable you are integrating with respect to. And then you'll use these templates to set up your integral. Taking a look at that may not be how you have seen it before, but the basic idea is that you're taking the top function and subtracting the bottom function, okay? All right, and so if you have a volume of a solid with a known cross-section, always sketch the region, draw a representative shape to know how you're setting it up, and then slice it with the same direction, and then make sure know that you have the face times the thickness. I actually like to think of it as volume as a 3D figure. And so you know that you're going to have the 2D is the area, and your integral kind of takes care of that volume piece, or I should say your 2D is your shape. So for example's name, instead of worrying about copying it wrong. So you've got this integral from dx. So that's kind of how I think about it. That's why I made sure I took a look at that. So then I just get 980 people. Okay, because I'm going to use my calculator. Anytime it's a calculator, okay, question, you should be making sure you use that calculator. There's no point in you doing anything differently. All right, taking a look at letter C. The total wait time for all the people in the auditorium is found by adding each time the person waits, starting at the time the person enters and ending with when the concert begins. Inside radiuses. All right, so let's get into some of these multiple problems. Typically, these are going to not be as complex because they're just testing your basic knowledge of these volume and area problems. So here I have the region enclosed by the x-axis, the line x equals 3, and I had the curve y equals square root of x rotate about the x-axis. What is the volume of the solid generated? Okay, so in case you forgot how to graph, this function right here, y equals square root of x, that is something you're definitely going to need to be held responsible for. So they are going to expect that you know how to graph that square root of x. You're not going to be able to get around that. So I know that it looks like this, right? And then they're cutting it off. They're telling me they're cutting this off at x equals. Now this is a calculator not allowed, and since 3 is not a pretty perfect square, it's pretty predictable that you're going to not need that point of intersection if it takes a calculator. So you don't need to panic about that. They want to know if it's rotated about the x-axis, what is the volume of solid that is generated? So I'm rotating about this x-axis right here. So notice that there's no hole cut out the middle. It's a solid area that I'm taking a look at. So I know I'm not going to have an inside radius. I'm just going to have the one radius. So I know my radius is going to be the square, using this word average. So in my head, I'm thinking, okay, is it an average amount or is it an average rate? So on average, how long? Well, that's not a rate. That's like an amount of time. So in my head, I'm thinking, okay, I'm probably going to be using this guy right here. Okay. So how long does a person wait in the auditorium for a concert to begin? Consider all the people who enter the auditorium after the doors open and use the model for the total wait time from part C. Okay. It's 9, so I do have that 9 over 2 pi. So that's a nice lower level, right? Because this represents the wait time. All right. Here I have the area of a region bounded by the line 0 to y, a curve y equals e to the x over 2. So this is a calculator not allowed, so it could look really scary at first. It is not that bad. Notice that all the multiple choice options leave things in terms of e, so it's probably one of those problems that adds to a panic. Okay, I'm taking a look at number 23. So this is a function that is twice differentiable for all real numbers. The table above gives values of f for selected points on this closed interval. They want you to evaluate the integral of 3 minus f prime of x dx. Show all that I'm looking for this area right here. Okay, so it's the integral from 0 to 2 of e to the x over 2 dx. Well, I know that I have this u substitution here, u or minus in an integral, because if they do, I'm of this e function. I use u substitution. Some of you can do just the integral of constant. I don't bother with it. So I have e to the u du 2 to 13. And so I'm thinking to myself, okay, I can do this first antiderivative here, no problem. Okay. I can just have 3n dx. All right, so I have the antiderivative. They're taking the antiderivative of a derivative to the u, 2 in front from 0 to 1. So 2 times e to the 1, which is just e, minus 2 times e to the 0. Now, AP, when they are talking to you about the value and whatnot, they really like to use this e to the 0, that it's equal to 1. So make sure you know this. So now I have 2 minus the quantity, don't forget to put this in parentheses, 5 times f of 13 minus 5 times f of 2. Do I have f of 13 and f of 2? You don't typically see something like this. And so the setup for it is probably the most difficult part. Okay, so if I take a look, I have the region bounded by, and then what, 39 minus 6, and you can simplify whichever way you want, but in the end you do get a value of 8. Okay, so one of the things that I will tell you that AP really loves doing is stuff like this right here. They really like making functions out of other functions with integrals and stuff, so that way they're really testing how well do you understand the relationship between all these different functions. So make sure you're watching out for that, but take a deep breath and just do what you think you would do, and odds are you're going to turn out with right. All right, oh, this is a classic one. I love this one. So if I take a look at this, I have the graph of g prime, so I'm going to make sure I make a note of that. The function g is defined and differentiable on this closed intervals and satisfied g of 0 equals 5. I know I'm going to need that for sure. The graph of y equals g prime, the derivative of g consists of a semicircle and 3 line segments as shown in the figure above. Okay, so they want me to find g of 3 and g of negative 2. So if I'm taking a look at g of 3, they do give g prime. Remember, I'm going to take a look at my relationships, right? They want me to work backwards. So remember, when you're going to the left on this relationship spectrum here, you're going to have to use your initial condition. So if I have g of 3, I know that I am going to take to pi over 2. This of g prime dx, but then I'm going to have to add my initial condition. So I'm going to add that 5, okay? So from 0 to 3, I'm going to have, so the antiderivative of cosine is sine. And I'm going from negative this right here, okay? So I have the quarter circle with a radius of 2, so that's pi times 2 squared over 4. And then I'm going to have to add my little triangle piece. Pi over 2 is equal to 3 times, and then I have to add my plus 5 times the sine of k. All right. That's it for g of 3. That's it. You don't need any more. Don't simplify it. Don't do that. This is good because it is completely numbers. So this is your g of 3. You think this piece here as the plus 1. And I'm this area right here. But keep in mind, I'm taking my integral from 0 to negative 2. So if I want to change it, so 0 to negative 2 of g prime of x dx plus 5, I'm going to actually make sure I keep in mind that this area right here, even though it's above the x-axis, since I'm going backwards, it's going to be a negative area. So it's this same pi times 2 squared over 4, but it's of when is sine equal to 1/2, okay? And hopefully you know that that is going to be when k is pi over 6, okay? Now, knowing that this much work goes into one choice problem, it is totally possible that you decide you would like to just skip it. Okay, maybe it's a little too difficult for you, or you don't think it's worth the time invested. But now, because we've talked about it, you know what a problem like this looks like, the different places you can make mistakes, and you can make better decisions about how you invest your time. Okay, all right, let's go ahead and take a look at number 4. Is equal to 4 square root of 4 plus the graph of y equals tan inverse and the horizontal line y equals 3 and the vertical line x equals 1. That's a lot. But for this solid, each cross section is perpendicular to the x-axis is a square. All right, so so g prime of x is going to be equal to, they tell me that g of x is f of sine of x, so that's going to be equal to f prime of sine of x of y equals 3. So I'm still in this little box, and I know my function does something in here. I already know what f prime of x is, but now I just need to plug. I'm taking a look at whatever this area is right here. I know each cross section is perpendicular to the x-axis, which tells me that I'm going to be using x values. Each one of those is a squared times 3 times cosine of x. And I don't need to simplify it. I don't need to make it pretty. I just need to make sure I put all my pieces together. Okay. These radii, I always think about it like, what if I was finding area? How would I find that length? And that's top minus bottom. So 3 minus tan inverse x, right? This is what each of the radii, the length of each one is. It's squared because I'm finding the area of a square, and I'm going from 0 to 1 dx. And there is no way I'm going to do this by hand, and by looking at my multiple choice, I can that I should totally be using my calculator unless I would like a headache. So I'm going to go ahead and do that, and you should get using the rules that I know. And then the other pieces fall into place because what and volume problems are either pretty simple or they let you use a calculator, and the setup is the hard part. Taking a look at number 5, again, you notice that I have a calculator allowed. It is really, really important, especially for this one, that you graph the functions that you're playing with. Okay, so if I take a look, the area enclosed by, I always graph the limit. Okay, so if I'm looking at maximum values, I'm probably looking at critical points. And so I'm going to be taking a look at when g prime of x is equal to 0. 2 areas that we're taking a look at. And these pictures aren't very pretty, but this is what I'm taking a look at. So I've got something that goes from 1 to 2, and another point of intersection over here at 5. Okay, so that means I'm going to have to set up, going to ever equal 0, right? One of the things that they're going to ask you to take a look at, and that they like to incorporate for some reason, if we look at our function right here, underneath here, it can never equal 0. Okay, so you should know that about your square roots and squares and stuff, right? Underneath here, you can't get something 0, and it's this 3 sign different integrals for 2 different areas. So the first integral is going from 1 to 2. The top function is the cubic function. And the bottom function is the linear function. Please, 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 please remember your parentheses. When we were taking a look at the mock exam grading, students who forget their parentheses, even if their answer is right, still lose a point. It's called a presentation error. And you really don't want to miss those silly points just because you forgot a parenthesis. All right, so you're going to have that area plus the area from 2 to 5. And in this one, the linear function's on top. Right? So if I have an FRQ and I do this without my correct parentheses, that's where I'd lose the point. Of course, with multiple choice, you wouldn't as long as you got the right answer. All right, so if I'm going to add these 2 areas together, I do get, with my calculator, value 11.833. Okay. So do not try to do any of these by hand if you are in a calculator allowed section. When we get to the FRQs, you see you're always going to have to show your setup, but you are not necessarily going to have to show your antiderivatives. So that's really important to keep in mind. Oh, this is one of my favorite problems. I think I've given a version of this problem to my students several times on their tests. So we have the regions of A, B, and C are in this figure, bounded by the graph, the x-axis. If the area of each region is 2, what is the value of the integral from -3 to 3 of f of x plus 1? Okay, so if I'm taking a look at this, just like I did before, I'm probably just going to want to split it up, right? I know how to do it for f of x, and since there's a addition in the middle, I'm going to split it because it's more convenient. And I know the integral from -3 to 3 for f of x is going to be, let's see, I've got -2, 2, and -2. So I've got an overall area of -2 plus, and you can take the antiderivative of this any way that you want. But I know the antiderivative of 1 is x, and from -3 to 3, that's just going to give me an area of 6, so I get an overall answer of 4. So make sure you watch that. So somebody's commenting that my video is green, so I'm going to go ahead and try to make some adjustments here. See what's going on. All right. Oh, hello. Back here. So if you're following along with the packet, I'm going to move over to 7. We're going to try to relaunch the desktop. And Sammy, if you're out there watching, can you let me know again if the video is still green? I want to make sure that we get that fixed. Okay. All right. So let's take a look. Sharing the entire screen. Taking a look at number 7. Now notice in this packet, and this should be very telling, in this packet, we are already going on to the free response questions. So what that tells me is that most of your area and volume problems are going to be coming from the free response questions. Okay, so here I have R. It's the shaded region in the first quadrant bounded by the graph of y equals 4 of natural log of 3 minus x. The horizontal line y equals 6 and the vertical line x equals 2. And notice, again, this is a calculator allowed. There is no reason for you to not be using your calculator on this. Okay, so they just want me to find the area. Typically with the area volume problems, they always have one of these lower level entry problems where it's simply finding the area. So you're going to have the top of the curve minus the bottom of the curve. So here the top is going to be at 6. You can see that at the top of the graph. The bottom is going to be the function itself. Okay, so if I'm finding the area, I am taking the integral from 0 to 2. Top is 6. Bottom is 4 natural log of 3 minus x dx. So you'll probably get 2 points just for the correct setup. They like to give you points for your integrand and your limits of integration. When you put this into the calculator, you'll get 6.816. Done. That is it. I kind of love the area problems that are calculator allowed. There's not a ton of places that you can mess up your algebra, and they're really valuing just the fact that you can see it and set it up. So again, for area, remember you have top curve minus bottom curve. The area is pretty straightforward. What more students seem to struggle with is the volume pieces. Okay, so the volumes generated when R is revolved around the horizontal line, y equals 8. Okay, so I always draw on my picture like a million times when I do this problem. So this is 6. Let's say 8 is right here. And they want me to revolve around it, generate, so revolved. Okay, so when I see this revolved, I know that I'm either talking about a disk or a washer. So I'm going to go ahead and make sure I check to see which one. If I take a look, I'm taking the area here and I'm rotating it around. So that means it's going to have to be, I kind of just flip it over and see what it has to look to be symmetrical. So I always reflect it over where I'm rotating so I can get that visual. So if I take a look at this, I'm going to see that I have a washer method because there's a hole cut out of the middle. I mean, like, look at this. Like, look at all that space. I'm definitely going to have a small radius I'm subtracting. So I need to be very careful about selecting what is my big radius, what is my small radius. So the big radius is going to be basically from this axis of rotation down to the furthest point. And this is when a lot of people have a hard time thinking of how to express that mathematically. I always like take a step back and say, whoa, if this was an area problem, how would I find the area? Top minus bottom. So the top here is 8. The bottom is the natural log function. So for my big R, that's going to be 8 minus 4 natural log of 3 minus x. And then for my little r, I'm going to go ahead and take a look at, okay, what is the little amount that I'd be cutting out? And that's 8 minus 6. You can express it as 8 minus 6, or you can express it as 2. Either way is totally okay. All right. So taking a look at the setup now, I'm just going to use the rule. Okay, if you're at a point where you don't understand how the rule works, don't sweat it. You just use it. You know, you have pi of big R. Oh, that should be an x. Big R, all in parentheses. Make sure you're very careful about your parentheses. Minus, and then I can say 2 squared, or I can say 4, or I can say 8 minus 6 in parentheses squared. AP will accept all of those. And then dx. Now my limits of integration are going to go from 0 to 2. So you get like 2 out of 3 points just for this beautiful setup. And then the last point just comes from putting in your calculator, 168.179. Okay. So as you can see, the amount of work that I put into drawing on this diagram is like absolutely insane. Please feel free to get carried away with it. And if you need a new problem, erase it and draw your next diagram. Make sure you bring a good eraser with you to the test. All right, let's go ahead and take a look at letter C. The region R is the base of a solid. For each solid, each cross-section is perpendicular to the x-axis. So I'm thinking in my head, hey, that means I'm in terms of x. And it's a square, so find the volume of the solid. So the square is going to have basically the same height as I had for part A, right? These heights, I'm going to erase some stuff up here so it doesn't look so crazy. Okay, the heights of the square are just these heights right here, but it's the same heights that I used in part A. So I know the area of the square is going to be 6 minus 4 natural log of 3 minus x, all squared. So I've taken into account the area of the square. Now to account for volume, so the area is 2D, and then I integrate to have my third dimension, and then I get a value of 26.266. So what I'll tell you about these, so this is pretty typical of an AP Calculus free response question. They'll start out with a pretty basic area that you can find with just the top minus bottom function. Sometimes you will have to find those points of intersection. Then they'll go to one of the either discs or washers, and then to one of the shapes. Not necessarily in that order, but those are the 2 kinds of volumes that they typically ask for. Now, it could be a square, it could be an equilateral triangle, it could be a isosceles triangle. Sometimes I've seen them talk about rectangles, where it's basically one of the sides is the height and the other one is like 5 times that value. So make sure you don't overthink it and just simply use what they state. So hopefully we'll see some of those as we keep going here. So taking a look at number 8. So I have the functions f and g. They give me the equations. They give me the graphs up there, which is really nice. Let R be the region bounded by the x-axis and the graphs of f and g as shown above. So there's actually a couple ways that you can do this, but let's go ahead and sketch out the area that they're looking for. Okay. So I'm thinking to myself, I don't always have the same top function. So I might need to change those limits of integration. I might need to split it. Or what I've seen some kids do As I've actually seen them change it to be in terms of y so that they can take a top minus bottom function. So I'm just going to keep it in terms of x, but do know that there is more than one way to take a look at this. So I have from 0 to 4. And so from 0 to 4, I picked that because that's as far as the square root function goes. So of the square root of x dx plus the integral from 4 to 6 of 6 minus x dx. Okay. So you can go ahead and just like take the antiderivative, see what happens, take a look from there. My screen is still green, so we may need to re-record some of this. I'm going to restart and see what happens here.